right, so today we're going to cover two lessons in Chapter 5. Lesson 2 is Sequences, and Lesson 3 is Properties of Operations. Please make sure you have these definitions written down. It says a sequence is an ordered list of numbers. Each number in a sequence is called a term. And an arithmetic sequence, in an arithmetic sequence, each term is found by adding the same number to the previous term. So, it says the number of students who went on each horseback riding trip is shown. Do the numbers represent the terms of an arithmetic sequence? And we want to explain. So, the first thing we need to do is we need to look at the patterns. So, if we're going from 15 to 16, how do I get from 15 to 16? Plus 1. Very good. And then from 16 to 18? Plus 2. Then 18 to 21? Good. And then from 21 to 25? Plus 4. So, the question is, do the numbers represent the terms of an arithmetic sequence?
Yeah.
Do they?
No.
Because in an arithmetic sequence, each term is found by adding the same number to the previous term. So here we're adding 1. Here we're adding 2, then 3, then 4. So is this an arithmetic sequence?
No.
No, it's not. Very good. All right, so we're going to describe and extend sequences. So here in an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. In this first example, we have whole numbers. We're going from 8 to 13 to 18 to 23. And each time, to get from the previous number to get to the next one, we're going to add 5. So 8 plus 5 is 13, 13 plus 5 is 18, and so on. So to get to the next 3 terms, you're going to add 23 plus 5. That gives me 28. And then you're going to add 5 to 28 to get 33. And then you're going to add 5 to 33 to get 38. So the next 3 terms are 28, 33, and 38. So here we have an example with decimals, okay? It's the same thing. We've got 4/10, 6/10, 8/10, and 1 whole. Now, to get from 4/10 to 6/10, we're just going to add 2/10. From 6/10 to 8/10, again, we're adding 2/10. So each time we're adding 2/10, so we can find the next 3 terms by adding 2/10 to the previous term. So for the got it, it says describe the relationship between the terms in each arithmetic sequence. Then we want to write the next 3 terms. So here they're telling us these are arithmetic sequences. So that means that we are going to end up adding the same number to the previous term. So how am I getting from 0 to 13? We're going to add 13. How am I getting from 13 to 26? We're adding 13. And how am I getting from 26 to 39? We're adding 13 again. Very good. So here, when I get from 39 to the next number, we've got 39. And of course, we're going to add 13 to it. So we're going to add 13 to this. And this is how I'd like for you to show your work. So 39 plus 13 is?
52. Yeah.
So there's the first term that we're looking for. Now we want to find the next one. So we're going to add 13. Very good. So that's going to be beautiful. And then we're going to add 13 again. Very good. And that's all there is to it. So for letter D, all right, let's do letter D. So let's see here. We're going to, because I want to do a decimal one. So how do I get from 2.5 to 3? We're adding 0.5. We're adding 1/2, right? And then from 3 to 3.5, we're adding 1/2 again. Very good. And then from 3.5 to 4, we're adding 1/2 again. Very good. 5/10. 0.5. So to get to the next 3, let's see, we're starting at 4.0. We're going to add 1/2. So that gets us to what? 4.5. Very good. Then the next term, we're adding 0.5 again. And that's going to give us 5.0. Very good. And we got one more term to find. So we're going to add another 0.5. Very good. So my final answer, my final term that we're looking for is going to be, very good. So now we're going to write an algebraic expression, okay? Now here, in a sequence, each term has a specific position within the sequence. So they are like in order, okay? So the first one is 2. So the order number is number 1. Does everybody see the position 1? The 4 is in the second position. So the position, that's position number 2. Does everybody see that? The third is a third position. The fourth position is 4. You see? Now, the value of the term, that's different. So it's 2, 4, 6, and 8. Ever see that in the chart? Okay? Now, when we are trying to figure out the expression, you have to look at the patterns in the table. So here, the position number, each time we're adding 1, right? For the value of the term, each time we're adding 2. Now, what's my delta y over delta x for this? Delta y over delta x is 2 over 1, which is 2, right? Now look at what's happening here. We're taking the position number and multiplying times 2. We're taking the position number and multiplying times 2. So each time we can take that position number, multiply times 2 to get the position value. Is everybody with me? So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and so forth. So we can say if n is the position number, we're going to multiply that position number times 2 to get the value of the term. So for example 3, we're talking about the greeting cards. It says the greeting cards that Meredith makes are sold in boxes at a gift store. The first week, the store sold 5 boxes. Each week, the store sells 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? And then we want to know what is the total. So here, finding the expression is we're finding it the same way that we found the expression in example 2. Okay, so here, if you look at the positions, they're increasing by 1 each time, right? Then over here, for the value, they're increasing by 5 each time. So what's my delta y over delta x? 5 over 1, right? So, or 5. And then look at what's happening. We're going to multiply times that 5. Is everybody with me? So you're going to multiply the position number, or the n, times the delta y of delta x, which is 5, and that's going to give us the value of the term. Does that make sense? So now it says to find out what is the total after the 100th week. So here you're going to evaluate the expression that you just wrote when n is equal to 100. So here you're just going to get your expression, then you're going to substitute, and then you're going to simplify to get your final answer. So at the end of 100 weeks, 500 boxes will have been sold. So here it says, for the got it, it says, if the pattern continues, what algebraic expression can be used to find the number of circles used in any figure? And then we want to know how many circles will be in the 50th figure. So if I'm looking at the picture and I want to fill in our table, we have figure 1, 2, and 3. So that's position 1, 2, and 3. Is everybody with me? So this is 1, 2, and 3. Now, how many circles do I have in figure 1? 3. How many do I have in figure 2?
6.
And how many do I have in figure 3? 9. Very good. Now, looking at our patterns again, each time here, you're adding 1, right? You're adding 1. And then over here, each time you're adding 3. So, what's our delta y over delta x?
3 over 1.
3 over 1, or just 3. So what am I going to do with that 3?
Multiply it by the position.
Very good. You're going to multiply it times the position. So that's going to be 1 times 3, 2 times 3, and 3 times 3. Very good. So the expression that we have, if we have our position, if our position is n, then we're going to multiply n times 3, and then algebraically, what goes first? The coefficient goes first, right? So here you're going to write 3n. So there is your expression, okay? So now it says how many circles will be in the 50th. So now we want to evaluate 3n when n is equal to 50. Very good. So now we're just going to substitute. So 3 times 50. And 3 times 50 is 150. So there will be 150 circles in the 50th figure. So lesson 3 is properties of operations. Okay? The properties. So a property is a statement that is true for any number. This is lesson 3. Okay? A property is a statement that is true for any number. Please make sure you write down your definitions. The commutative property. Commutative property states that the order in which numbers are added or multiplied does not change the sum or the product. So in other words, a plus b is the same thing as b plus a. Or a times b is the same thing as b times a. That's the commutative property. So here on this, I would like for you can write the property, and then you can write for addition and multiplication, you can write the general terms. Okay? The associative property states that the way in which numbers are grouped when they are added or multiplied does not change the sum or the product. Okay? So this is one where we're grouping. Okay? We're changing the parentheses. So here for the addition, we are moving the parentheses from the second 2 to the first 2. Okay? And vice versa. Either way. And same with multiplication. Now let me ask you this. Does the commutative property hold true for subtraction or division?
No.
Let's check it out. So for subtraction, we're just going to pick two numbers. Okay? Let's do 5 minus 2. Okay? So 5 minus 2 is 3. And 2 minus 5 is negative 3. So those are two different numbers, right? Two different numbers. So that means the commutative property does not hold true for subtraction. What about for division? Let's do 1 and 3. Okay? So 3 divided by 1 is 3. But 1 divided by 3 is 1/3, right? So they're very different, and so it does not hold for division. And that's also the same for the associative property. It does not hold, the associative property does not hold for subtraction or division. Okay? Now, those were reviews for you. Here, these properties down here, I want you to make sure you write these down also. You can write the general form, the name of the property, and the general form. Okay? We've been working with these properties forever. You know these are true, you just did not have a name for them. Okay? So the additive identity says when 0 is added to any number, the sum is that same number. So you've known that forever, right? So any number plus 0 is that same number. The multiplicative identity, okay? That means, that says that when any number is multiplied times 1, the product is that same number. We've known that forever too, right? Okay? The multiplicative property of 0. When any number is multiplied times 0, what are you going to get? 0. Those are the properties. You already have been working with them forever. You just did not have a name for them. So now you do. So in example 1, we're going to name the property shown by the statement. So here we have 2 times the quantity n times, 5 times n. And then we have the quantity 2 times 5 times n. So here, what you're seeing is happening is that the parentheses are moving from the second 2 to the first 2. So if the parentheses, if we're grouping differently with 3 numbers, that is going to be the associative property. And I do want you, when you are naming your properties, I want you to be specific. This is the associative property of multiplication. So looking at example A, it says 42 plus x plus y is equal to 42 plus y times x. Well, we have 3 numbers, but we have no parentheses, right? So there must be something else going on. Okay, so if we look at what's happening with the x and the y and the x and the y, what's happening there? They're switching around. So x plus y is equal to y plus x. What property is that? Commutative property of addition. Very good. So what about example B? Example B says 3x plus 0 equals 3x again. So we added 0 to a number and we got that same number. What property is that? The additive identity. Very good. So let's go ahead and write that down. That is the additive identity. And you don't have to write of addition because that's where the additive comes from, right? Or comes in. Now, a counter example. We already talked about this a little bit at the beginning. It says you may wonder if any of the properties apply to subtraction or division. Well, if you can find a counter example, which is an example that shows that a conjecture is false, then the property does not apply. So a counter example is an example that shows that a conjecture is false. And of course, a conjecture is just a statement, okay? A statement that somebody's claiming something. So, example 2 says, state whether the following conjecture is true or false. If it is false, provide a counter example. So it says division of whole numbers is commutative. So we want to find 2 examples where it's not going to be true, okay? So 2 division expressions. So we did 15 divided by 3. 15 divided by 3 is 5. And then flip it around with the commutative property, 3 divided by 15. That's 1/5, right? So 5 is not equal to 1/5. That is my counter example. That is false, so that tells me that the conjecture is not true, is false. So it says the difference of two different whole numbers is always less than both of the two numbers. Okay, that's the conjecture. So we want to come up, if we can come up with an example that is false, okay, that this is not true, then that statement is false, right? So, a counterexample. Yes. 100 minus what? 50. Okay, 100 minus 50 is equal to 50. So, is this number less than 100? Less than 100? Yes. Is this number less than 50? No, it's equal, right? So, this is my counterexample. That tells me that this is not true. So for example 4, it says simplify each expression and justify each step. So here we're looking at 7 plus g, the quantity of 7 plus g, plus 5. Now, when we are simplifying, we want to make sure that there are no like terms. So right now, the like terms that we have available here are 7 and 5. So somehow we need to get those together so that we can combine them. Okay, so the first thing we're going to do to get the 5 and the 7 closer together is we are going to use the commutative property. Does everybody see this? You're going to use the commutative property to switch those. So we have 7 plus g and g plus 7. So we use the commutative property there to switch those. So now we have the 7 and the 5 are closer together. So now I'm going to take the parentheses and move from the first 2 to the second 2. What property is that? When you are grouping differently. That's the associative property of addition. And now, because we have those two together, now we can add them and we end up with g plus 12. So, for example E, we want to simplify. And once again, we want to put all of our like terms together. Okay? So, we want to see if we can get the 4 and the 2 closer together. So, the first thing we're going to do is what? Can I just switch them over,
Yeah.
using the commutative property? So here, this is going to be 4 times the quantity 2 times 3c. Okay, so this was the commutative property of multiplication. Is everybody clear? All right. Now we have these together. Now I'm going to switch the parentheses. So I'm going to put the parentheses from here, from the first 2, to the second 2. And from the second 2 to the first 2. Right? So we're going to have 4 times 2, and that's going to be in parentheses, times 3c. So this is going to be the associative property of multiplication. I'll write the whole word later, okay? So now we have 8 times 3 times c. So here I just simplified, right? And now when I simplify, I can put my 8 and my 3 together, simplifying more. That's going to give me 24c. Is everybody clear? All right. So you did the work, and then this is how you justify each of the steps.